Hi, welcome. I'm Ryan Hoger. Today we're going to be going through ventilation systems for your small and mid-sized commercial buildings, talking about them specifically from the perspective of a packaged rooftop unit, although the same logic would apply to any system that you have for your HVAC. So the reason why you want ventilation air. Indoor air in a building is typically significantly worse than the outdoor air for people's comfort and health, right? People are in the building, they cough, they sneeze. There's certain paints that are used on the walls that give off VOCs. There's finishings on the tables. There's cleaning chemicals. So what we want to do is suck outside air into that building to bring fresh air in to dilute down all of those pollutants that are in the building. So the way we're going to do that typically is with our packaged rooftop unit. So this guy right here, he sits on your roof. He's got heating and cooling and everything built in. And this hood right here is where the fresh air comes in. So fresh air from outside gets sucked in under this hood. Very similar to opening up a window at your house, for example. So it's going to get sucked in here, mixed with the other air that's in the system, heated and cooled if needed, filtered, and sent down into the space downstairs. So that fresh air comes in here. The reason why we have the hood is so if it's raining or snowing or whatever, the water doesn't get in with it. We just want the air. So rain will hit here, but air will come in underneath. There's a little grate under here to protect like bugs and birds and stuff from getting in there, and then that air can be sucked straight in through that grate. All right, so our first question is, how much outside air do we need to bring in to ventilate a particular building? So to find that number, you could turn to your local building codes, your state or municipal code. Generically today, we'll use the International Mechanical Code, because that's obviously kind of covers everything. Or you can use ASHRAE Standard 62.1. Both of that and the International Code have the same tables in there. So we're gonna take a look at this table right here. This is just like page 1 of like 5 tables. What you do is you find your specific type of building, because it's a little bit different, like a school needs a different ventilation rate than say an office building would. So you find the type of building that you have. We'll use an office example in our case. And then most of these columns you're going to ignore because they're metric, and you're only going to pay attention to 2 columns. One is the CFM per person. So that's how much ventilation air do I need to dilute down the people-related pollutants. So my body odor, whatever cologne I'm wearing, my cough that I came in with this morning and showed up for work with, whatever it is. And the other portion is the per square footage or the building portion of the ventilation air I need. The bigger the building, the more furnishings it has, the more paint it used, the more cleaning chemicals it used. So we dilute down for that volume as well. So we'll take the office building example. We need 5 CFM per person, as the math shows here. And let's just say we have 100 people in this building to make the math easy. That's 500 CFM we need for the people. And then we have 0.06 CFM per square foot for an office building. And let's do 10,000 square feet because it makes the math easy. I'm all about easy math today. That's 600. And the 600 plus the 500 means I need 1,100 CFM of outside air. CFM is cubic feet per minute. It's the normal volume of measurement we would use for airflow, whether it's this intake hood or whether it's a fan system or whatever it is. All right, the final step here in our math journey and ventilation journey is to figure out how much outside air we're actually bringing in right now. We know we want 1,100 CFM of outside air. How much do we actually have? Now, most of us don't have expensive air balancing equipment to go measure that, but we do have some kind of temperature probe. Whether it looks like mine or whether you got a pencil probe, something like that, we can take some temperature readings and do a little bit more math and figure out how much air is coming in through this outside air opening. So we got to measure 3 temperatures. You need to do this on a day when it's either a little bit cool or a little bit warm. It can't be a day where all the temperatures are the same because it's mild outside. So in this case, let's pretend we have a 10-degree day outside. I can either go just stand outside with my temperature probe, or I can go up on the roof and put it in front of the inlet here. It should be basically about the same. Let's say it's 10 degrees. I need to take a mixed air temperature reading, which if I go to the supply duct and put this in the diffuser coming out of the supply, and my system is not running heating and cooling, my mixed air temperature and my supply air will be the same. So that's the easiest place to get that. I'll take the probe again and I'll put it in the return duct or at the return grill going back to my system. So I got the outdoor air temperature, I have the supply temperature, which is also the mixed air temperature, and I have the return temperature. That return air and outside air mix together to make up my mixed air / supply air coming into the building. So if I know their temperatures, I know how much is coming from each of those openings. So I got 10-degree outside air, 70-degree return, 50 mixed air in this example. That makes my math here show I have 20 divided by 60, which is 33%. 33% of that air is coming from the outdoors. How much air am I moving through my fan system? So I need to know how much air my system moves. If you don't know, you could at least say hey, I'll use the old school 400 CFM per ton assumption. Let's say in this example, I have 5,000 CFM system, 33% of it comes from outside. That means I have 1,650 CFM from outside right here. I only need 1,100 in this case. I could throttle this system down a little bit so I bring less outside air in and only bring in the amount that I need. If my number came out low and let's say it was only 700, then I need to raise that damper position up to bring in more fresh air. Adjusting the damper position of the economizer is a whole separate training video exercise, but I think you get the idea of how you can at least A, know why you need ventilation air for health and safety, B, how much do I need for my specific building, and then C, how much do I actually have right now. Hopefully you guys find that useful, and we'll see you on the next video.